Welcome everyone to the first lecture in this series of 4 by Professor Adrian Moore on the history of the infinite. My name is Sebastian Sunday-Grave. I'm an assistant professor of philosophy at Peking University, as well as a member of the Chinese Institute of Foreign Philosophy, and it will be my honor and pleasure to be your moderator during these 4 lectures. Professor Moore is both professor of philosophy and lecturer in philosophy at the University of Oxford, as well as tutorial fellow of St. Hugh's College, one of the constituent colleges of the University of Oxford. He studied philosophy as an undergraduate at King's College, Cambridge, and did postgraduate work at Balliol College, Oxford, where he obtained his doctorate under the supervision of Michael Dummett. He has held teaching and research positions at University College, Oxford, and King's College, Cambridge, but since 1988, he has been at St. Hugh's College in Oxford, and he was vice principal of that college from 2017 to 2020. From 2014 to 2015, he was president of the Aristotelian Society. Since 2003, he has been Bernard Williams' literary executor. Since 2015, he has been joint editor, together with Lucy O'Brien, of the famous philosophy journal, Mind. He has published many books and articles, including the monumental The Evolution of Modern Metaphysics, first published in 2012 by Cambridge University Press. The most recent of his books are the 3rd edition of his influential The Infinite, published by Routledge in 2019, and a collection of some of his essays under the title Language, World, and Limits, Essays in the Philosophy of Language and Metaphysics, published by Oxford University Press, also in 2019. In this lecture series, Professor Moore will talk about some of his long-standing and ongoing research on the infinite. And this series of lectures is entitled A History of the Infinite. There will be 4 lectures in total over the period of 10 days, Wednesdays and Fridays. I would like to thank the institutions who are mainly supporting the lecture series, namely Peking University, and in particular my department, the Department of Philosophy and Religious Studies at Peking University, and also the university's Office for International Relations, as well as the Chinese Institute of Foreign Philosophy. Many people at these different institutions have worked very hard to make this event possible, and I would like to personally thank all of them for what they have already done and also for their commitment to what is still to come. The lectures are being live streamed both on Bilibili and on YouTube, and it's planned that recordings will be uploaded to these platforms too. Furthermore, the print publication of the lectures in Chinese translation is already underway. And what this great shared effort shows, I think, is the significance of this event and similar ones from an intercultural perspective. The academic and popular exchange of scientific and perhaps especially philosophical ideas between East and West is without a doubt amongst the most important elements of any effort to achieve an increased intercultural understanding. In this world at a time when modern information technology has brought people around the world ever closer together, but often not, or not yet enough, in such a way that they could actually understand each other on something like a fundamental human or intercultural level. And it is certainly the hope of the people and institutions who have organized this event that it may achieve some such understanding. And to achieve this, there must naturally be exchange of ideas, ideally an interchange of ideas. And to enable this kind of exchange, each lecture will be followed by discussion. There will be an audience Q&A, questions and answers, but there will also be a panel discussion at each lecture. And we have been very lucky to be able to attract many great experts from various Chinese universities to join the panels of the 4 lectures. And so it is now my honor and pleasure too to welcome our panelists today. Today, we are very lucky to welcome Chen Bo of Wuhan University. Hello. And Wang Wei from Fudan University. Wu Tianyue, my colleague at Peking University, and another colleague at Peking University, Zhao You. Hello and welcome to you all. Thanks for accepting our invitation. I will introduce each panelist in a little bit more detail later on after the lecture at the beginning of our panel discussion. And after the panel discussion, we will have the Q&A that I mentioned. So that means that throughout the live streams on both Bilibili and on YouTube, we will be collecting short questions and comments, which we then intend to present to Professor Moore so that he may answer some of them. All of the selected questions and comments will also be shared with him after the event. So now it is time to begin our first lecture. The title of the first lecture is The Infinite in Ancient and Medieval Thought. So it's my great honor and pleasure again to welcome you, Adrian, Professor Moore. Now, please, it's your time, and you're welcome to begin your first lecture. Welcome.
Unmute myself. Thank you very much indeed, Sebastian, for that introduction. And thank you very much indeed for the invitation. It's a great honor to give these lectures, and I really appreciate the invitation that you extended to me. And I'd like to join you in thanking the various institutions that have made this event possible, and to thank the various panelists who will be responding to my lecture. I'm going to begin by sharing my screen with you. So I hope that's worked. And this is a handout that I will be scrolling through in the course of the lecture. And you'll notice straight away that there is some material on the handout that is in red, and there is some material on the handout that is in black. And the difference between the two colors is simply that the red material is quotations from other people, and the black material is material of my own between the quotations, summarizing the main lines of thought. So this lecture begins with some material in red. I want to quote from David Hilbert. This is a famous quotation. David Hilbert wrote as follows: "The infinite has always stirred the emotions of mankind more deeply than any other question. The infinite has stimulated and fertilized reason as few other ideas have. But also the infinite, more than any other notion, is in need of clarification." Now, David Hilbert was a famous 20th century mathematician, and this is from an address that he gave in 1925 on the nature of the infinite. And I'm beginning with that quotation, not because it's especially relevant to the infinite in ancient and medieval thought, but simply because it's a reminder of what an important topic this is. Throughout the centuries, people have thought about the infinite, tried to understand the infinite, and struggled with the infinite. As David Hilbert says, it is a notion that stands in need of clarification. Now, I will be, throughout these lectures, presenting a kind of history of thought about the infinite. But it's worth emphasizing straight away that by thought here, I mean Western thought. I'm specifically going to be interested in how thinkers in the West have grappled with this notion over the last 2,500 years or so. And as I say on the handout, it would be great if at some point in the question and answer session, people were able to present ideas from Eastern thought, perhaps that are very similar to those that I'm discussing, or perhaps that stand in contrast with those that I'm discussing. But if I learned something about Eastern thought during the course of these lectures, that would be great. Now, there's an old adage, an old saying that the Greeks abhorred the infinite. They distrusted it. They couldn't really make sense of it. They thought that it was something basically to be avoided. And as I say on the handout, there is some truth to this old saying. Pythagoras, who lived in the 6th century BC, was a famous philosopher and famous mathematician. I think all of you will be familiar with Pythagoras's famous theorem about the square on the hypotenuse of a right-angled triangle being equal to the sum of the squares on the other two sides. But as I say, he was a philosopher as well as a mathematician. And he built up a school. He had various followers, and they were known as the Pythagoreans. And they divided the world into two fundamental cosmic principles. And one of these they called peras, and that's the Greek word for the limited or the finite. And the other they called apeiron, which is the Greek word for the unlimited or the infinite. And they thought that peras, the first of these principles, subsumed everything that was good, and the latter, apeiron, subsumed everything that was bad. So there you see this stark contrast between the attitudes that they took to the finite and to the infinite. And they actually thought of apeiron in physical terms. They believed that apeiron was a kind of surrounding to the visible heavens, the physical universe that we're familiar with. They thought that the physical universe that we were familiar with was finite and was surrounded by apeiron. And what the physical universe did was, as it were, breathe in this surrounding apeiron and overcome it, subject it to a kind of finite order, impose a kind of finite order on it. And that was part and parcel of this cosmic battle that they recognized between peras and apeiron, between the finite and the infinite. Now, I say that they thought that peras subsumed everything that was good and apeiron subsumed everything that was bad. And later we find Aristotle summarizing their views as follows. So here's some material in red. This is a quotation from Aristotle talking about the Pythagorean view. And Aristotle writes as follows: members of the Pythagorean school say that there are 10 first principles, which they arrange in 2 parallel columns thus. First of all, limited and unlimited. So that's peras and apeiron. And those are the 2 principles at the head of the columns. But then there were these 9 other associated distinctions: odd and even, one and plurality, right and left, male and female, I'm sorry to say. So this is some early Greek sexism that you find. They thought that what was male was good and what was female was bad. Resting and moving, straight and crooked, light and darkness, good and bad. So there you find it quite explicitly, square and oblong. And here's Aristotle again summarizing the Pythagorean view, which I myself summarized a little earlier. All those who are thought to have made a significant contribution to natural philosophy have given some account of the infinite, and all posit it as a sort of first principle of the things that exist. Some, like the Pythagoreans, make it a principle in its own right, supposing that the infinite exists itself as a substance. They locate it among perceptible objects and say that the space outside the heavens is infinite. The Pythagoreans also say that void exists and that it enters the heavens from the infinite breath, as though the heavens actually inhale the void. So there's this idea of the physical universe breathing in the surrounding void or the surrounding apeiron, and everything in the physical universe can be understood in finite terms. And in particular, the Pythagoreans thought that the counting numbers, the natural numbers 1, 2, 3, 4, 5, etc., were very important, because it was in terms of these counting numbers, these natural numbers, that everything in the physical universe had to be understood. So here we are, the Pythagoreans thought they could explain the world around them in terms of the natural numbers, 1, 2, 3, 4, etc. The numbers that we use to to count finite collections of things. But they were dismayed when they discovered that it was not so, that it was not as they thought. And I won't go into details about the discovery now. I'll say a little bit about it. We can talk some more about this in the Q&A session if people would like me to come back to it. But the discovery was related to Pythagoras' own theorem about the hypotenuse on a right-angled triangle, the square on the hypotenuse of a right-angled triangle. So if you can imagine a square, and if you can also imagine the diagonal of that square, the question arises, what is the ratio of the diagonal to each side? If you were to measure the diagonal of a square, and if you were to measure each side of the square, what would be the ratio of those measurements? And it's roughly 7 to 5, roughly. But roughly is the crucial word there. It's not exactly 7 to 5. And so the Pythagoreans were interested in what exactly the ratio is, which natural numbers can be used to measure this ratio. And what they discovered, and as I say, we can talk some more about this later if you would like me to, but what they discovered is that there are no natural numbers that register this ratio. 7 and 5 come quite close, and there are other combinations that come even closer, but there are no natural numbers that can be used to tell you exactly how big this ratio is. And so that that went to show that not everything can be understood in terms of the natural numbers as they thought. And so this was a very upsetting discovery for them, a devastating discovery for them. And as you can see on the handout, according to legend, one of them was actually shipwrecked at sea for revealing this discovery to their enemies. Now, a little later, so Pythagoras was lived in the 6th century BC. A little later, we come across the famous thinker Zeno of Elea, who was living in the 5th century BC. And he was somebody who also thought a lot about the infinite. And in particular, he was interested in the infinitely small. He was interested in what happens when you divide quantities up into smaller and smaller units. If you divide space into smaller and smaller portions, for example, what happens? And when he was thinking about these issues, he discovered a lot of paradoxes involving the infinite and also involving motion. Motion is important because motion involves both space and time. And these paradoxes were paradoxes about space and time. So again, let me scroll down to another quotation from Aristotle. So this is Aristotle later talking about Zeno and about Zeno's paradoxes of motion. And Aristotle writes as follows: Zeno's arguments about motion, which cause so much disquietude to those who try to solve the problems that they present, include the so-called Achilles. Now, Achilles is the name that's given to one of Zeno's paradoxes, and perhaps the most famous of Zeno's paradoxes. And I'll say a little bit later about the Achilles paradox. But first of all, let me continue with this quotation so that you can see what Aristotle says about it. Aristotle says, this, the Achilles paradox, this maintains that in a race, the quickest runner can never overtake the slowest, since the pursuer must first reach the point where the pursued started, so that the slower must always hold a lead. Now, that's very typical of Aristotle in as much as it's a very brief statement of the paradox. And if you haven't come across the paradox before, that probably won't mean much to you. I suspect that most of you have come across the paradox before and are already familiar with it. But just in case you're not, let me say a little bit about it. And here's an illustration of the paradox. So what Zeno did was he asked us to imagine a race between Achilles and a tortoise. And of course, Achilles runs very fast and the tortoise is much, much slower. So if it was a normal race, it wouldn't be at all interesting. So in order to make it a little bit more interesting, the tortoise is given a head start ahead of Achilles. So at the beginning of the race, there's a big gap between Achilles and the tortoise. And in this diagram, we imagine that Achilles starts at the point where it says step 1, and the tortoise starts at the point where it says step 2. So as you can see, there's this gap between Achilles and the tortoise at the beginning of the race. And then the race starts. Somebody fires the starting gun and the race starts. And Achilles starts running very fast and the tortoise starts running very slow. Now, Achilles, we assume, will eventually overtake the tortoise. But first of all, before Achilles can do that, the very first thing that he's got to do is he's got to get as far as step 2, the point at which the tortoise starts. And of course, he can do that. Achilles can run from step 1 to step 2. And the tortoise is much slower, but nevertheless, the tortoise is also making some progress. And in the time that it takes Achilles to get from step 1 to step 2, the tortoise advances from step 2 to step 3. And that's a much smaller gap because the tortoise is so much slower than Achilles. Nevertheless, the tortoise is still ahead of Achilles. So now what Achilles has to do is he has to get from step 2 to step 3. And of course, he can do that, no problem. But in the time that it takes him to do that, the tortoise will make some more progress. And in the diagram, you can see that that's the step from step 3 to what is marked in the diagram as T. And so now there's a new gap that Achilles has to make up. And you can see how the argument is going. The gap between Achilles and the tortoise is getting smaller and smaller, but always the tortoise is ahead of Achilles. And it looks as if Achilles is never going to be able to overtake the tortoise. And that's the paradox. We started off thinking that it would be quite easy for Achilles to overtake the tortoise, but this paradox shows that Achilles can never overtake the tortoise. And this is Zeno's famous paradox called the Achilles, or the paradox of Achilles and the tortoise. And as I say, this is probably Zeno's most famous paradox, although he had lots of others as well. And we can talk about the others if people would like to in the Q&A session. Now, most people, when they first encounter this paradox, think that it's a puzzle that we have somehow got to solve, and that there must be something wrong in the argument, and we must be able to find out what's wrong in the argument. But actually, Zeno himself came to the conclusion that motion was impossible. He thought that this paradox and some of his other paradoxes showed that there's no such thing as motion. And what he believed was that the appearance of motion really is just an appearance. The world presents itself to us in such a way that there seems to be motion. But when we actually think about motion, as we are doing in this paradox, we find that it's contradictory and that it doesn't make sense. And therefore, what Zeno concluded was that there's no such thing as motion, and the real world doesn't involve any motion. The real world doesn't involve space or time. Space and time themselves are just part of how reality appears to us. That was Zeno's conclusion, and he was following his great master Parmenides in drawing this conclusion. And there were a lot of Greek thinkers who would have agreed with him, but there were also a lot of ancient Greek thinkers who would have disagreed with him. And so they would have taken the view that this is a paradox that we still need to solve in some other way. Now, let's turn our attention to Aristotle, who came later in the 4th century BC. And I've already quoted from Aristotle, a number of quotations from Aristotle discussing other people's ideas, but Aristotle had some very important ideas of his own about the infinite. And Aristotle was keen to bring about a kind of reconciliation because he could understand why the Greeks abhorred the infinite. He could understand why they were wary of it and thought that it didn't make sense. But he also believed that we couldn't really avoid thinking about the infinite, and that in some ways the infinite is a fundamental part of reality. Some things just do go on forever in Aristotle's view. So somehow we need to be able to explain why the infinite does exist, and also we need to be able to explain the sense in which it doesn't exist. And we need to explain why the ancient Greeks, the other ancient Greeks, were so uncomfortable with the infinite. So as I say on the handout, he sought a reconciliation between the idea that things can go on forever on the one hand, and on the other hand, the fact that the Greeks abhorred any such idea and that there is something suspicious about the infinite. And so what Aristotle did was he drew a very, very famous distinction between what he called the potential infinite and what he called the actual infinite. Now, this distinction has subsequently been very influential, and people have understood it in various different ways. But I think it's important to emphasize right from the very beginning that Aristotle's own way of understanding this distinction was in temporal terms, in terms of time. This is a distinction that has to do with time. And the way it goes is this: the potential infinite is a kind of infinity that is spread out over time. So, for example, if you imagine a clock endlessly ticking, and that ticking goes on and on forever and never stops, then that would be an example of something that was potentially infinite. That ticking, the ticking of the clock, is spread over time, it never ends, and it's potentially infinite for that reason. Whereas the actual infinite is a kind of infinity that is present all at once. So, for example, if the physical universe was spatially infinite, suppose that space goes on forever, and suppose that the physical universe fills the whole of space, then that would be an example of an actual infinite, because that would be a kind of infinity that is present all at once. So Aristotle draws this important distinction between the potential infinite, which is spread out over time, and the actual infinite, which is present at a particular point in time. So the clock, let's go back to the clock. The clock's ticking is potentially infinite because that is spread out over time, but it's never actually infinite. I mean, at any given time, you've only ever got, one tick of the clock. And also at any given time, the ticking that it has done up until that time is only finite. So it's going to carry on ticking forever. And what Aristotle said was that the reason that we're a bit confused about the infinite, the reason why we sort of want to say that it exists and we want to say that it doesn't exist, is because we haven't properly taken into account this distinction. And in Aristotle's view, the potential infinite is fine. There are examples of the potential infinite. Time itself is potentially infinite. That goes on forever and ever. The numbers that we use to count 1, 2, 3, 4, those are potentially infinite because you can keep counting forever, and that would be a process that would be extended over time. But the actual infinite is always bad in Aristotle's view. There cannot be any such thing as the actual infinite. You can't have an infinity that's present all at once. So, as I put it on the handout, Aristotle argued that the former, the potential infinite, and the former alone was the acceptable face of infinity. So let's look at Aristotle's own way of summarizing this. Here's what Aristotle says. It is plain that there is no body which is actually infinite. So in other words, Aristotle is just taking as given that no physical thing is actually infinite. No physical thing can be infinite because that would be an infinite that was present all at once. But on the other hand, to suppose that the infinite does not exist in any way leads obviously to many impossible consequences. There will be a beginning and an end of time. A magnitude will not be divisible into magnitudes. Number will not be infinite. So again, what we see here is we see Aristotle pointing out the various ways in which the infinite does exist. Time goes on forever. You can count forever. If you've got a space, you can keep on dividing it up into smaller units because the process of division will go on forever. And those are examples of the potential infinite. So to carry on with the quotation, if then neither alternative seems possible, an arbiter must be called in. And clearly there is a sense in which the infinite exists and another in which it does not. Now, magnitude is not actually infinite, but the alternative then remains that the infinite has a potential existence. So that's Aristotle's view. No actual infinity, but yes, there is a potential infinity. And here he summarizes his view about how the infinite does exist potentially. The infinite exhibits itself in different ways. In time, in the generations of man. So Aristotle thought that human beings would keep existing forever and ever. And in the division of magnitudes, you can divide a spatial magnitude forever and ever. You can keep on making smaller and smaller divisions. For generally, the infinite has this mode of existence. One thing is always being taken after another, And each thing that is taken is always finite, but always different. And those two occurrences of the word always are crucial, because that shows you the element of time, the temporal element that's coming in. Aristotle is making the point that the infinite exists because there's always more to come in this process. Now, as I say on the handout, one thing that Aristotle thought that he could do was solve Zeno's paradoxes and explain why they can be solved without doing what Zeno himself did. That's to say, without denying the very possibility of motion. So how does Aristotle think that he can solve Zeno's paradoxes? And in particular, how does he think that he can solve the paradox of Achilles and the tortoise? So perhaps it would help if I go back to the diagram. So what Aristotle says is, look, Achilles will eventually overtake the tortoise. So in the diagram, that's going to be a little bit beyond the point mark T. And that's no problem, says Aristotle. Achilles can certainly do that. What's happening in this paradox is that we're dividing his journey up into smaller and smaller units. So first of all, we divide it into the bit from step 1 to step 2, the point between where Achilles starts and where the tortoise starts. And then we can recognize the division between step 2 and step 3, and so on and so forth. And if we wanted to, we could actually mark those points. I mean, after the race, once it's over and once Achilles has overtaken the tortoise, we could go back and we could put a little flag at step 2, and we could put another little flag at step 3 if we wanted to. We can keep on dividing the space that Achilles has to traverse in order to overtake the tortoise. But that's a potential infinity. It's not an actual infinity. And what that means is that however many of these divisions we've made, we can always make more divisions if we want to. But the number of divisions that we've actually made is always going to be finite. And there's nothing that Zeno actually does that involves an infinity. I mean, there's nothing that Achilles actually does that involves infinity. I mean, he could, if he wanted to, shout out at some of these points. So when he gets to step 2, he could shout out, I've got to step 2. And when he gets to step 3, he could shout out, I've got to step 3. Those are things that Achilles could do. But he could only do finitely many of those. I mean, by the time he's overtaken the tortoise, he might have shouted out 6 or 7 times. He can't shout out at all of those points because that would involve an actual infinity. But this is not a paradox. Aristotle says the only infinity that's involved here is a potential infinity. That's fine. Zeno can overtake the Achilles can overtake the tortoise in a way that involves that potential infinity, but not in a way that involves any actual infinity. So let's go back to Aristotle himself. So Aristotle says, here's another quotation from Aristotle, this concludes my account of the way in which the infinite exists and of the way in which it does not exist and of what it is. That's the quotation from Aristotle. And this was nearly 2,500 years ago that Aristotle was presenting these views, and they have been enormously influential. There are still lots and lots of people who think that Aristotle was basically right about the infinite. And there are still lots and lots of people who want to draw the same sort of distinction between the actual infinite and the potential infinite. And there are still lots of people who believe that there's something problematical about the actual infinite, whereas the potential infinite is perfectly okay. So Aristotle's views, as I say, have been very, very influential. But a lot of people who have copied Aristotle in distinguishing between the actual infinite and the potential infinite have not totally copied Aristotle, in as much as they haven't understood it in literally temporal terms. So I kept trying to emphasize that for Aristotle, this was a distinction having to do with time. Later thinkers often use metaphors that have to do with time, but they don't mean them literally. They try to understand the distinction in a more abstract sense, which can be spoken of in temporal terms, but isn't literally a temporal distinction. So you find later thinkers who talk about the numbers going on and on forever, but unlike Aristotle, they're not thinking about a literal process of counting. They mean going on and on forever in a more metaphorical sense that doesn't have to do with time. But at any rate, there are lots and lots of thinkers who basically take an Aristotelian view. And so now I'm going to give you an example, and this is the next quotation on the handout. Now, Sebastian, in his introduction, mentioned that I studied with Michael Dummett. Michael Dummett was my doctoral supervisor. And the next quotation on the handout is a quotation from Michael Dummett, a very famous 20th century philosopher who thought a lot about infinity and wrote a lot about infinity. And he's a good example of somebody who basically adopts an Aristotelian view of infinity. And I think that comes out quite clearly in this quotation from Michael Dummett. So Michael Dummett writes as follows: "It's quite literally true that we can arrive at the notion of infinity in no other way than by considering a process of generation or construction which will never be completed." The Platonist, now I should stop at this point and explain that by the Platonist, what Dummett has in mind is someone who thinks of the infinite as actually existing all at once, whether literally or metaphorically. So the Platonist is somebody who believes in an actual infinity. And Dummett says, the Platonist destroys the whole essence of infinity, which lies in the conception of a structure which is always in growth, precisely because the process of construction is never completed. the Platonist conception of an infinite structure as something which may be regarded both as the outcome of a process and as a whole, as if the process were completed, rests on a straightforward contradiction. The infinite process is spoken of as if it were merely a particularly long, finite one. So that's Dummett saying, look, if you're a Platonist, you're sort of contradicting yourself. You're treating the infinite as if it was just something very big. You're treating this never-ending process as if it had finally come to an end and resulted in something that was infinitely big. But a never-ending process never does come to an end. That's the whole point. And to treat it as if it did come to an end is, as Dummett says, a straightforward contradiction. Now, so far I've been concentrating on ancient Greek thought, and we've been going back almost 2,500 years. Well, in fact, at the beginning, over 2,500 years. And now I'm going to take a big jump, and we're going to jump all the way ahead to the medieval period, where Aristotle's views continued to be very influential. And in particular, this was because of the famous medieval thinker, St. Thomas Aquinas. As I say on the handout, he acted as a kind of intermediary. And he lived in the 13th century. So we've taken a very, very big jump. We've gone from the 5th century BC to the 13th century. But Aquinas was somebody who was very much under the influence of Aristotle. He believed that Aristotle was the greatest philosopher of all time, and that most of what Aristotle said, if not everything that Aristotle said, was right, and that we had to follow Aristotle as far as we could. But St. Thomas Aquinas was also a Christian thinker, and in particular, he was a member of the Catholic Church. And so what he had to do was he had to try to explain how Aristotle's views and Christian views could be reconciled, because Aquinas wanted to subscribe both to a kind of Aristotelianism and remain faithful to his own Christianity. And this presented him with a bit of a problem, because there are some ways in which it looks as if Aristotle's views and the teachings of the Catholic Church are in conflict with each other. So, for example, the traditional Christian view, the traditional Catholic view of God, is that God is omnipotent. God can do absolutely anything. On the other hand, as we've seen, Aristotle denied that there could be an infinitely big body, that any physical object could be actually infinite. So straight away, it looks as if there's a bit of a tension here, because doesn't this mean that, after all, God is not omnipotent? Here's something that God can't do. God can't create an actually infinite physical body. So there's a problem straight away for Aquinas. There's one thing that Aristotle says, and there's something else that the church says, and they seem to be in conflict with each other. And Aquinas has got to explain how they can be reconciled with each other. And the way that Aquinas tries to solve this problem is as follows, and here's a quotation from Aquinas. He says, although God's power is unlimited, he still cannot make an absolutely unlimited thing any more than he can make an unmade thing. For this involves contradictory statements, both being true. So let me try to explain this quotation. Aquinas is saying, no, God can't create an absolutely unlimited thing, or in Aristotle's terms, God can't create an actual infinite thing. God can't make an actually infinite thing. But that's not really a limitation on God's omnipotence, says Aquinas, because that's just a matter of logic, and not even an omnipotent being can violate the laws of logic. That's not what you expect of an omnipotent being. An omnipotent being is a being that can do anything that's logically possible, but an omnipotent being can't make contradictory statements true. An omnipotent being can't make something that isn't made. That was Aquinas's way of getting around this problem. Again, this is something that we can talk about in the question and answer session if people would like to. Other thinkers have disagreed with Aquinas about this. There are some thinkers who would say that if God really is omnipotent, then God should be able to violate the laws of logic. Not even the laws of logic are a constraint on God if God is omnipotent. But that's not Aquinas's view, and that's Aquinas's way of trying to get round this particular problem. But it's not the only problem. It's not the only problem that Aquinas faces. And there's another problem which in some ways is even more obvious, and in many ways is even more serious, which is, what about God himself? Surely God is infinite. And yet, according to Aristotle, nothing that actually exists is actually infinite. So what is Aquinas going to say about this? What about God's own infinite properties, God's own infinitude? Well, again, Aquinas thinks he has a solution to this problem. For one thing, we have to realize that God does not exist in time. So if we recall that Aristotle's distinction is a distinction about time, we don't have to think that God's infinitude is present all at once, all at a particular point in time, because God is not in time at all. So in a way, that's the simple way of trying to get round this particular problem, this particular difficulty. But also, relatedly, there's a distinction that we can draw, a very important distinction, which I haven't mentioned at all so far, between what you might call a metaphysical sense of infinity, or a theological sense of infinity, and a mathematical sense of infinity. And up until now, all of my discussion has been concerned with the mathematical sense of infinity, which is concerned with measurement and quantity, that idea of larger and larger magnitudes. The metaphysical sense of infinity is more a matter of quality than it is a matter of quantity. And what Aquinas would say is that God is metaphysically infinite, but not mathematically infinite. So Aristotle's distinction between the actual infinite and the potential infinite is not really relevant to God, because Aristotle's distinction is a distinction to be drawn between two different kinds of mathematical infinity. So again, Aquinas thinks that he's okay. He thinks he can continue to believe everything that Aristotle says about the infinite, and that he can continue to believe the doctrines of the church as well. And this was very influential. And Aquinas enjoyed quite a lot of success in trying to bring about this reconciliation between Aristotle and the church. And eventually, these views themselves became orthodoxy. The church itself embraced Aristotle's teachings because of the work of Aquinas. And for a long time, a lot of the basic doctrines of Christianity were Aristotelian doctrines. And philosophers would only step out of line with this at their peril. It was a very dangerous thing to do. If you disagreed with the teachings of the church, you could be in serious trouble. I mean, in very serious trouble. A lot of thinkers were actually executed because of the way in which they denied doctrines of the Christian church, the Catholic Church. And one of the most famous examples was Galileo. And he's famous, perhaps above all, because he agreed with those thinkers who believed that the sun was at the center of the universe, not the earth. Galileo's view was that at the center of the universe, we find the sun, and the earth rotates around the sun, whereas the Catholic Church had taught that the earth is at the center of the universe. So Galileo was somebody who was in serious danger and took issue with the church, disagreed with the church, and was eventually forced to recant some of his views. But he didn't just disagree with the church as far as the question of what is at the center of the universe is concerned. He also disagreed with the church on some of these questions of infinity. And he believed that we could make sense of an actual infinite. He was quite comfortable with the idea that the numbers 1, 2, 3, 4, 5, etc., all exist at once. That's no problem as far as Galileo is concerned. We don't have to think of this in terms of an endless process of counting. We can think of this as a collection of mathematical objects that are all there together at the same time. And as far as Galileo was concerned, that is an example of an actual infinity. So this goes right against Aristotle, and it goes against what had by then become the Orthodox Christian view as well. Now, there's a little bit of an irony because, as you can see on the handout, although Galileo accepted the existence of the actual infinite, this was despite the fact that he discovered some paradoxes of his own concerning the infinite totality of natural numbers. And these are paradoxes that were subsequently very important as well. And those of you who attend my third lecture, lecture 3, will see me returning to some of these paradoxes. They're very important in the subsequent mathematical study of the infinite, which is what I shall be discussing in lecture 3. But already Galileo was aware of these paradoxes, paradoxes concerning the collection of natural numbers 1, 2, 3, 4, 5. And if I scroll down, you'll find this is a quotation from Galileo in which he outlines one version of the paradox. And it goes as follows. This is Galileo's quotation. If I should ask how many squares there are, so the square numbers are just 1, 4, 9, 16, 25, etc. If I should ask how many squares there are, one might reply truly that there are as many as the corresponding number of roots, since every square has its own root and every root has its own square, while no square has more than one root and no root has more than one square. So here's an illustration of that. This is the first 10 numbers. On the left-hand side, you can see the first 10 natural numbers. And on the right-hand side, you can see their squares, 1, 4, 9, 16, 25, etc. And corresponding to each natural number on the left-hand side, there's exactly one square on the right-hand side. And corresponding to each square on the right-hand side, there's exactly one natural number on the left-hand side. So that's the illustration. Now let's continue the quotation. So this is Galileo again. But if I inquire how many roots there are, it cannot be denied that there are as many as there are numbers, because every number is the root of some square. So over on the left-hand side, you've just got all the natural numbers. They all occur there. Yet, it seems that there are many more numbers than squares, since the larger portion of them are not squares. So over on the right-hand side, you've got gaps. Let's go back to the let's go back to the diagram. Over on the right-hand side, you've got the natural numbers, but with gaps in between them. So it goes straight from 1 to 4. We're missing out 2 and 3. And then it goes straight from 4 to 9. We're missing out 5, 6, 7, and 8. So not all the natural numbers are appearing on the right-hand side, but they are all appearing on the left-hand side. Not only so, but the proportionate number of squares diminishes as we pass to larger numbers. So the gaps on the right-hand side are getting bigger and bigger. There are fewer and fewer squares as you keep on going. So up to 100, we have 10 squares, as you can see. That is, the squares constitute 1/10 part of all the numbers. Up to 10,000, we find only 1/100th part to be squares. And up to 1,000,000, only 1,000th part. So the proportion of squares is getting smaller and smaller all the time. So this is a paradox. This is a paradox that Galileo has discovered concerning the natural numbers. On the one hand, it looks as if there are as many squares as there are natural numbers altogether because they can be paired off. On the other hand, it seems obvious that there are fewer squares than natural numbers, and indeed, they're getting fewer and fewer as you travel out along the sequence. So how did Galileo himself solve this paradox? Because there he is telling us that he believes in the collection of natural numbers as an actual infinity. Well, here's what Galileo says. So far as I can see, we can only infer that the totality of all numbers is infinite, and that the number of squares is infinite, and that the number of their roots is infinite. So these collections are all infinite, infinitely many numbers, infinitely many squares. And, says Galileo, the attributes equal, greater, and less are not applicable to the infinite, but only to finite quantities. So what Galileo is saying is that we just mustn't talk in these terms. It doesn't make sense to compare infinite collections in size. The problem that we get into is that we think it makes sense, we run into contradictions. It looks as if we should say that there are as many squares as numbers altogether. It looks as if we should say that there are fewer squares than numbers altogether. We're not quite sure what to say. Galileo's solution to the paradox is, well, don't say any of these things. Don't talk in these terms. Those labels are no longer applicable when it comes to infinite collections. Now, when we get to lecture 3, those of you that attend lecture 3 will find later thinkers revisiting this paradox and taking a very different view, and arguing that we can talk about some infinite collections as being bigger or smaller than other infinite collections. But I won't say any more about that now, because that is a topic for later. That's a topic for lecture 3. But that is the point at which this lecture stops. So I shall finish at that point and I shall stop sharing.
Thank you ever so much, Adrian, for that wonderful first lecture today. Now, we have plenty of time for discussion. We've got 45 minutes left. We will begin, as I said earlier, with our panel discussion. So I invite our panelists to rejoin by opening their video cameras again. If they like, I will briefly introduce our panelists. I will begin with Chen Bo. The order is alphabetical. Chen Bo is now chair professor of humanities and social science in the School of Philosophy at Wuhan University until very recently, September 2021, and since September 1999, he was a full professor in philosophy at Peking University. He's a titular member of the Académie Internationale de Philosophie des Sciences and a permanent titular member of the Institut International de Philosophie. He has been a visiting scholar or professor in the last 25 years at many universities, including the University of Helsinki, following an invitation by Georg Henrik von Wright, at the University of Oxford also, following an invitation by Timothy Williamson, as well as universities in the United States and Japan and elsewhere. His research is mainly in logic and analytic philosophy. And he has published very many books and articles in various languages and a large range of philosophical problems. Welcome again, Chen Bo. Wang Wei is a lecturer in the School of Philosophy at Fudan University in Shanghai. He works mainly in ancient philosophy with a focus on Aristotle's theoretical philosophy and ancient metaphysics in general. He has recently published a monograph on Aristotle's theory of mover and causation with Peking University Press. Welcome, Wang Wei. Wu Tianyue is an associate professor in the Department of Philosophy and Religious Studies at Peking University and a member of the Chinese Institute of Foreign Philosophy. He obtained his doctorate from Catholic University Leuven in 2007. He works mainly on ancient and medieval philosophy, in particular theories of mind, emotion, morality, and free will. His book, Voluntas et Libertas, a philosophical account of Augustine's conception of the will in the domain of moral psychology, was published by Peking University Press in 2010. His articles have appeared in journals such as Res Philosophica and Oxford Studies in Medieval Philosophy. Currently, his research is focused on Aquinas' philosophical anthropology and freedom and responsibility in ancient and medieval philosophy. Welcome again, Wu Tianyue. Finally, Zhao You, another colleague here at Peking University. Zhao You is an assistant professor in the Department of Philosophy and Religious Studies. Her research and teaching are mainly in the transmission of Buddhism from India to China and early Indian metaphysics and linguistic philosophy. Currently, she is leading a project on the philosophy of time in Indian philosophy, funded by the Chinese National Social Science Fund. And most of her recent publications are also focused in this area of research. Welcome again, Zhao You, and welcome everyone. Now we have time for discussion. I think that Professor Chen Bo would like to start sharing some of his views. Please welcome Professor Chen.
Yes. Thanks to Professor Moore's wonderful lecture, and also thanks to Sebastian's friendly introduction. Professor Moore present infinite paradox from the historical perspective. Let me know what great philosophers in the past think about infinity, very informative and very clear. Thank you. Yes, I have two questions. One is that in your handout said Professor Grace makes support that the infinite exists in itself as a substance, and also they locate it among perceptible objects. I'm wondering how they make this whole position coherent. This way, how the infinite as a substance exists into many different perceptible things. As the object exists many different perceptible things. How to make this coherent with each other? This is the one question. The second one is that according to your presentation, Aquinas says that even God have to follow logic. He cannot do things logically impossible. If this is right, I'm wondering how to reconcile the two positions. according to Christianity, God is omnipotent, can do everything. But according Aquinas, logic have to follow. God have to follow logic. So this is a paradox. I want to know Aquinas how to respond to the stone paradox. In sum, God can do what he cannot do. That God can do what cannot do. For example, he can create a stone. He himself cannot hold up. This is my question. Thank you. Yeah.
Adrian, you can answer if you like. Okay.
Yes, I wasn't sure, Sebastian. Sorry, you explained this to me yesterday, and I'd forgotten what the format was. You want me to respond to each person in turn rather than wait for all four?
Yeah, I'm not sure we talked about it, but yes, I assume that was a good way of doing it. If you like to do it that way.
No, I think that is a good way to do it. Yes. So, I mean, there's a lot to be said in answer to these two questions. I shall try to keep it as brief as possible. The Pythagorean's view is a curious one. The view is that the infinite, or apeiron, has a kind of physical existence, and in particular an existence in space, and more specifically the space beyond the natural world that we're familiar with. So they believed that that world was finite, but there was a space further out which contained apeiron, and it's a substance in the same way that physical substances are substances, but there's an interaction between apeiron and what we see in the world around us, and this is part of what they had in mind when they talked about the way in which the world around us is kind of breathing in this outside apeiron, breathing it in and then subjecting it to various laws of nature which are imposed on it. But in the quotation from Aristotle, the infinite is talked about as if it were itself perceptible. And you picked up on that. And I think that is actually a little bit of a mystery. There's a sense in which that's not quite the best way to put it, because all that's perceptible is what's part of the physical world around us. And that's not where apeiron appears. I mean, it's always a little bit difficult with these brief quotations from Aristotle to know exactly what's the best way to interpret them and exactly what he has in mind. But one way of trying to explain why Aristotle puts it this way is to say, well, look, by the time you've got things that are perceptible, by the time you consider the physical world round about you, Peras and apeiron have both been involved. I mean, that the forces of good, the forces that come under the head of Peras, have imposed a kind of law and order onto apeiron, which they've subjugated, and so it is in a way perceptible because it's part of what contributes to the perceptible world around us. So I think that's the story about why Aristotle puts it in the way that he does. Now, as regards Aquinas and the idea that God can only do what's logically possible. Now, as I mentioned in the lecture, not everybody has agreed with Aquinas about this, and there are some thinkers who believe that if a being really is omnipotent, then it ought to be able to do even things that are logically impossible. But that was not Aquinas's view, and Aquinas said, look, when the question arises, what is it possible for an omnipotent being to do, we have to limit our attention to what is possible in the first place. I mean, the question is, given what's possible at all, how much of that is it possible for an omnipotent being to bring about? But you've got to restrict attention to what's possible in the first place, otherwise your question doesn't make sense. That's Aquinas's view. But then you quite rightly point out that there are various paradoxes that still arise. And in particular, there's a famous paradox about whether God could create a stone that is so heavy that not even God can lift it. And this really does look like a paradox, because if we say no, then it looks as if after all, there's a limitation on God's omnipotence. On the other hand, if we say yes, then that's a limitation on God's omnipotence as well, because there's a stone that's too heavy for God to lift. I'm ignorant, I'm afraid, and somebody else here will probably know better than I do. I don't myself know of anywhere that Aquinas explicitly discusses this problem. I'm sure he does somewhere, and I'm sure other people will know what Aquinas says about this. But I think what's going to be crucial is whether you think that God's omnipotence is a necessary property of God's or only a contingent property of God's. Because basically what we're doing is we're asking whether God can take away his own omnipotence. Now, if it's logically necessary that God is omnipotent, then Aquinas's answer is going to be no. Can God create a stone that's too heavy for him to lift? No. And that's not a paradox, because that's just another example of something that's logically impossible that God can't do. And we've already admitted that God can't do what's logically impossible. So that's okay. On the other hand, if you thought that God's omnipotence was only contingent, that God could exist without being omnipotent, then the answer is going to be straightforwardly yes. God can create a stone that's too heavy for him to lift. And if he did do that, and if he then was confronted with this stone that he couldn't lift, well, again, there's no paradox. He can't lift it because he's no longer omnipotent, and that's because he's destroyed his own omnipotence. So it's all going to depend on whether God's omnipotence is necessary or contingent. I assume that Aquinas thinks it's necessary, and I assume that's how he solves this paradox. But as I say, other people are probably going to have a better idea of that than I do.
Thanks very much, both. I suggest that perhaps we do follow the alternative format for the following exchange anyway, just so that we perhaps avoid it from happening that we have one relatively long exchange and then some of our panelists will perhaps not be able to say everything they want to say, and we want to make sure that we hear from all of our panelists. So what I mean by that alternative format is what Adrian actually suggested we may have started out with, which is to say that each panelist now will have an opportunity to make their points, ask their questions, whatever they wish to contribute, one after the other. Before then, Adrian is going to try to respond to all three of you. I hope that that is that is okay and agreeable for everyone. I don't know who would like to start. Anyone, or should I pick someone? Oh, Tianyu, yes, please. Thank you.
Thank you very much. Thanks a lot to Professor Moore for your very interesting talk. Actually, I have two questions. The first question is about Aristotle's solution of Zeno's paradox, Achilles paradox. You mentioned in your talk that we can imagine Achilles finish a task when he tries to catch turtles. For instance, when he finished step 1, he shout out. When he finished step 2, he shout out again. And if we think in this way, then it means that before Achilles finished the race to catch the turtles, he seems to need to shout out for an infinite number of times. Yeah, that means that he needs to finish infinite numbers of tasks within a finite period of time, which seems which seems impossible. Yeah, at least it seems impossible. So I would like to hear your comments how one can finish infinite number of tasks within a finite time of period of time. Sorry. And the second question is about your comments on Aquinas, and as you mentioned, Aquinas makes several distinctions of different types of infinity. In his own terms, he makes a distinction between infinity regarding to matter or infinity regarding to form. He also makes a distinction between infinity in essence and infinity in magnitude. First, I'm not quite sure if the latter distinction, the distinction between infinity in essence and infinity in magnitude, is corresponding to your distinction between metaphysical and mathematical senses of infinity. If that's the case, I think the passage you cited only shows that God cannot create something that is infinite in essence. Yeah, because if a created thing is infinite in essence, it will not be created, because being created means that its being is limited by the action of being created. But we cannot directly derive from this conclusion that God cannot create a thing that is infinite in a mathematical sense or infinite in magnitude. So I would like to hear more about your understanding of Aquinas' arguments against the actual infinite in a mathematical sense. Okay, thank you very much.
One way, please go ahead.
Okay, so thank you very much, Professor Moore, for the wonderful talk, and thank Peking University for the invitation. I'm very glad to be here. So I have a kind of a comment, but questions also, sort of general question in the comments. So my question is about, or starts from Zeno's paradox. We know that Aristotle mentioned Zeno's paradox of motion in his physics. And in those are questions that has to do with motion. And in Simplicius's commentary on Aristotle's physics, he introduces another set of two paradoxes which plays on the idea that if there are many things, then the many things are limited, both limited and unlimited, and so on. And it seems that in that other set of paradox, the crucial idea is between, or Zeno plays on, is the distinction between the discrete and the continuous, discrete quantity and continuous quantity. And seems to be the case that around the time of Zeno, the Greeks are grappling with this kind of problems. So the problem is whether, so there seems to be two kinds of ontologically different things. One set is points, and however many points you add up together, you can't get the continuum. And however you divide, the continuum cannot get to the points. And which partly is shown in the Pythagorean columns of opposites. And also it has to do with things, for example, in Anaxagoras' discussion of infinite division and so on. And also in terms of how the atomists come about and try to push against that kind of thing and say that there are, if you divide things many times enough, you get to the indivisibles. And we see this not only in the atomists' account, but also in the account, for example, in Xenocrates, the student of Plato, who has sort of this mysterious thing about the indivisible magnitude, the discussion of which we also find in the Aristotelian corpus. So my question is a general one, so in what sense do you think that this kind of understanding also plays into the discussion of infinite in your account of the ancient Greek thinking? And do you think that Aristotle has sort of the solution to the infinite problem on the basis of potential infinite only solve the motion problem? Or do you think that it also has something to do with the problem of discrete and continuum? And also from the Aristotle perspective, it seems to me that for Aristotle himself, at least, he seems also to sharply distinguish between two kinds of things. One, the limits themselves, and the thing limited. For example, soul and body plays into this kind of dualism. Whereas people like the atomists or the Epicureans or the Stoics, on the other hand, if they believe in sort of the monist kind of thing, they would think that the thing that limits, we used to limit the thing limited, are of the same species or kind. So they share the same ontological status. So that's my general comment and question. So do you think that the problem having to do with potential infinity has anything to do with the problem of discrete and the continuous things? Okay, thanks. I hope this does not steal any thunder from your future talk of infinitesimal. But that's my question. Okay, thank you very much.
Very good. Thank you for that. Jalio, would you like to add your comment or question at this time too?
Okay. Thank you very much, first of all, Professor Moore, for your very thought-provoking lecture. And many thanks to Sebastian, who invited me to be one of the panelists, regardless of how little I know about this topic. So I'm working in a totally different field. So I try to think along with the points you brought up. I'm not sure if I can convey the ideas that have come to me in the last 1 hour, but I will try. In the beginning, you mentioned that the Greek were appalled by the infinite. I guess for the Indians, they were appalled by the finite. So I guess it was a totally opposite beginning of the story. Probably I'll start with the Vedic people. They lived 3,000 years ago, and they arrived at this appreciation of the infinite, I suppose largely from their ritual life. For example, they discovered the diagonal in making bricks of the fire altar. So that was about 3,000 years ago, maybe much earlier than that. And they tend to understand the infinite always in a temporal way more than not. Because when they did all those sacrifices of different scales, they understand this action as kind of engagement in the continuous creation of the universe. So in that sense, their sacrifice or their actions were for the operation of the world to continue without an end. I guess that was the start of their appreciation of infinity. Then when we come to the Upanishadic period, which is about 7th or 8th century BC, we came to the idea of Brahman. I guess most of us have come to this word, which is often translated as the absolute. But nowadays we more often to take it as a vision of totality. And this totality seems to go beyond the temporal world. But again, this absolute, this Brahman is always defined as endless. It is true, it is knowing, it is limitless, as the tradition always describe it. And these endless kind of absolute or the highest deity or the highest being, this idea was then inherited by later theistic discourses, like one of the opposites of Vishnu, one of the gods, is Ananda, which is limitlessness. I found one idea in the Upanishads quite interesting because they, from time to time, they mention this idea that there are more than fullness or more than completeness. I'm wondering, I guess that's one of the questions or one of the curiosity I have in my mind now. So is there this idea of something more than fullness in the Western tradition? So for example, in Chandogya Upanishad, the limitless is said to be 1/4 of the Brahman. So as I mentioned, Brahman is the totality. It is the fullness, it's the absolute, but at the same time, only 1/4 of that totality is called limitlessness. Of course, it's all those ideas in the Upanishads were quite speculative, lack of full arguments. So we can only try to understand that there seems to be something more than an earlier idea of limitlessness, or there seem to be two ideas of the infinite. Well, this is more of the positive part of these the infinite. At the same time, there are also quite negative kind of infinity. For example, their idea of these always circling time, which is called Garba. According to Eliot, it's a doctrine of cosmic cycles, which expounds the periodic creations and destructions of the universe into staggering proportions. And similarly, the idea of samsara, which is the beginningless rebirth based on the retribution of individuals' karmas. All of these kinds of infinite, always continuous process were understood to be rather negative than positive. Apart from that, also infinite regress was one of the principles the Indian philosophers accepted. I still remember quite vividly that once after a lecture, we were working towards a canteen, and I had this very naive question: why the Indians sort of accept the fact that the rebirth is infinite, or there's some infinite kind of absolute, but at the same time they cannot accept this infinite regress. I guess I was too ignorant to understand what my colleague offered me, but well, so the question about infinite has been with me perhaps since then. well, yes, that's perhaps what I want to say now, because we have not much time left. Okay, thank you very much again.
Thanks to you. Thanks to all of our panelists for their great contributions. And I do think that we do have enough time left. In fact, at least if Adrian, you could try to limit yourself to 10 minutes total in responding to these 3 questions and comments. That'll give us roughly 10 minutes for the final Q&A. Yeah? Okay. Thank you.
Well, thank you very much for these comments. I mean, there's actually a huge amount that could be said in response to them. These are excellent comments. And so I'll try to limit this as best I can. And so what I have to say in response will be quite sketchy, I'm sure. But let me take the questions in the order in which they arose. So first of all, Wu Chang, 2 questions, one about Aristotle's solution to the Achilles paradox, and then questions about Aquinas. As far as Aristotle's solution to Zeno's paradoxes is concerned, you raised once again a possibility that I myself mentioned in passing in the lecture. What about the case in which Achilles shouts out every time he reaches one of the crucial points on the journey? By the time he gets to the point where he overtakes the tortoise, it looks as if he will have shouted infinitely many times, and it looks as if that should count as an example of an actual infinity rather than a potential infinity, because it's eventually all over, and so it's there all at a particular point in time. And so it's a good point, and a lot of subsequent discussion of these paradoxes has been concerned with problems of that kind. I think what Aristotle himself has got to say is that the story just doesn't make sense, and I think what he's got to say is, look, we think it makes sense because we think we can imagine little flags at all the critical points. I mean, these flags have got to be getting smaller and smaller and smaller so that they can fit in. But we think we can imagine these flags, and we think we can imagine that at any point on the journey, when Achilles passes one of these flags, he can shout out. And of course, he's got to be shouting quicker and quicker as well. But actually, what's going on, Aristotle would say, is that all that you ever in fact have are finitely many flags. I mean, you can put in a huge number of flags. You could put 1 million in if you had small enough flags to get them to all fit in, but it still would always be finite, and all that Achilles would be able to do would be to shout out finitely many times. Why there's a potential infinity there is that however many of these flags you've planted, it will always be possible for you to plant more. And that possibility is to be thought of as an endless ongoing process. I mean, that possibility we can think of as being realized over time as more and more divisions are made, but not as being realized in time. If you're anti-Aristotelian, it can just look as if he's begging the question. And that's what a lot of subsequent thinkers will have said. They just disagree with him and say, look, we can imagine somebody performing an actual infinity of tasks in a finite time. But I think that's what Aristotle himself is going to have to say, whether it's question begging or not. Now, as regards Aquinas and his various distinctions, you mentioned in particular the distinction between infinite essence and infinite magnitude. And you asked me whether that was the same as what I meant by the distinction between the metaphysical and the mathematical. Basically, I think it is the same. I mean, I'm not really enough of an Aquinas scholar to be able to answer this with confidence, I'm afraid, but I suspect that's essentially the same thing that I had in mind. I mean, what I had in mind was quite indeterminate anyway, because the distinction between the metaphysical and the mathematical is one that I think of as reappearing in various different forms throughout the history of thought about the infinite, and I wouldn't just want to apply it to Aquinas. So I think probably the best thing for me to say is that his distinction between essence and magnitude is one version of the distinction between the metaphysical and the mathematical. But then you raise a problem, which is you say, well, as far as that quotation goes, doesn't this just go to show that Aquinas is denying that God could make anything that's infinite by essence, not that God could make anything that's infinite by magnitude? And if the latter is what's at stake, we still need to know what his argument is. And I just have to admit that I don't know Aquinas well enough to be able to comment on that. It may well be that you're right about that, and that this is a comment about the infinite by essence, in which case it means that I've not chosen the best quotation. But I am sure that we will also find Aquinas wanting to deny that God can make anything which is, in Aristotle's terms, actually infinite, a kind of infinite magnitude. And so he is going to want to say something similar about that, even if that's not what he's doing in this passage. And then you raise the question, yeah, but then what's his argument? I mean, his argument as far as essence is concerned is simple appeal to contradiction. The infinite by essence can't be created. And so, of course, God can't create such a thing. But what's the argument to show that he can't create something that's infinite by magnitude? And the argument, I think, is going to be whatever Aristotle's argument is. I mean, so this is going to be an example of Aquinas deferring to the master, if you like. I mean, Aristotle has already taught us that there's something fundamentally incoherent about the actual infinite. And whatever it is that Aristotle's taught us, and however he's managed to teach us it, that then carries over to what God can do. Now, Wang Wei raised some fascinating questions about divisions of magnitude and whether these are to be understood discretely or in terms of continuity. And this is a really interesting set of questions that reappears throughout the history of philosophy. And in fact, we will find examples of this perhaps in Friday's lecture. It depends how much I cover on Friday, but you find a version of this kind of discussion in Kant, for example, raising the question of whether things can be divided up until you eventually reach what's indivisible, or whether processes of division carry on forever. As far as that distinction is concerned in relation to Zeno, I think there's something to be said for the view that what Zeno is doing is arguing against the possibility of motion, however it's understood. So if you think of motion in discrete terms, there are certain problems that you encounter. And if you think of motion in terms of continuity, there are certain problems that you encounter. The Achilles paradox is one of those paradoxes that seems to be targeted at motion when it's understood in terms of continuity. But there are other paradoxes due to Zeno, and there's one paradox in particular which seems to be targeted at the possibility of motion if it's understood in discrete terms. So I think Zeno is trying to cover all bases, as it were, and present problems for motion however it's understood. As for Aristotle, I think his view is that we have to think of what's physical or what's spatial in terms of continuity, in the sense that it is infinitely divisible. I mean, if you have a long stick in front of you, you've got something infinitely divisible. You can chop it in half, and then you can chop each of the halves in half, and then you can chop each of the quarters in half, and so on and so forth. That's an illustration of a kind of continuity, a kind of infinite divisibility. Do you eventually reach something that's indivisible? Do you eventually reach points? No, will be Aristotle's answer to that question, because you don't eventually reach anything. And the point being that this is yet another example of a potential infinity rather than an actual infinity. So however many cuts you've made, you can carry on making more and more cuts, and the pieces are getting smaller and smaller and smaller, but it never finishes, and you never reach the point that you've got something that's indivisible. I think that's going to be Aristotle's view, and that we don't want to think of something like a stick as made up of indivisible points. I mean, there is. I mean, you did also talk about the difference between limits and what does the limiting. One point that's perhaps also worth flagging in connection with Aristotle is that he thought that the physical universe was spatially limited. It had to be, otherwise there'd be an actual infinite. So space itself for Aristotle is finite or limited. And a natural objection to that is, well, what's it limited by? I mean, what is there that's outside space? If space is only finite, what is there that's outside space? Now, as it happens, subsequent developments in physics have sort of vindicated Aristotle, and physicists these days talk about space as being finite and limited, although they understand that in a rather different way from Aristotle. But what both of them would say, what both Aristotle himself and physicists would say, is that for something to be limited, it's not necessary that it should be limited by something else. Those limits can, as it were, be internal limits, part of the very essence of the thing. And then thirdly, Zhao Yu, this was really interesting.
Sorry, Adrian. I'm very sorry to interrupt you. I just wanted to make it known to everyone that whilst we've hit the hour now, which is the end of the scheduled live stream, my suggestion is that we should not have that dictate what's happening, because we can simply continue for a while, and I'm sure that many, or indeed most people, will be happy to stay with us. And you can take your time. And after that, we will have a little bit of a Q&A with our audience. And the panel can, of course, always continue their discussion in private later. So please take your time, and we'll do the Q&A afterwards. Okay.
Thanks. I probably should have said, I think I mentioned this to you yesterday, Sebastian. I will have to go at 1:15 at the latest. So even I'm a little bit limited, I'm afraid. But
we will stop before that.
Yeah. Let me say something very briefly in response to Xiao Yu, which so this was really fascinating, and you've done exactly what I was hoping that somebody would do, which is you've introduced some Eastern thought as well, and discussed some of the comparisons, and there obviously are some very interesting comparisons, and I just really found that very interesting. I don't have a lot to say in response, actually. I mean, this will be very brief. Just a couple of things. I began my lecture by saying that the Greeks abhorred the infinite, and you mentioned that, and you pointed out that with some ancient Indian thought, it was very much the other way round. And in subsequent Western thought, it's tended to be the other way round as well. But it is worth noting that even what I said about the ancient Greeks was an oversimplification. And the first Greek thinker who really talked at any length about the infinite was Anaximander. And actually, if you go right back to Anaximander, it tends to be the other way around. I mean, you think of the infinite as a rather important, a good cosmic principle. It was not really until the Pythagoreans that we got this interesting reversal. And that was partly because they found it so hard to make sense of the infinite. But obviously, there's always a danger with these things of oversimplifying, and to some extent I did oversimplify. But you also had some really interesting things to say about the absolute and the distinction between a positive and a negative understanding. And let me just say that there will be a little bit more of this in lecture 3, which may come as a little bit of a surprise to you, because that's the lecture in which I'm going to be talking about the mathematical treatment of the infinite. But the person who was most famous for studying the infinite in mathematical terms was a 19th century mathematician, Cantor. And Cantor was a brilliant mathematician, but he was also very religious. And I'm hoping in lecture 3 to talk a little bit about some of his religious views. And I think that we may find that there are some interesting connections between some of his religious views and some of what you were talking about. And in particular, we find Cantor using this term, the absolute. And in particular, he uses that term when he's thinking about God, but he also believes that some of his own mathematical discoveries help to illustrate what is meant by the absolute. So perhaps, I don't know whether you're going to be able to come to the 3rd lecture, perhaps you won't be at the 3rd lecture, but if you are there, you might see that there are some further connections with the Eastern thought that you were talking about.
Thank you ever so much, Adrian, for those very interesting elaborations in response to the comments and questions from our panel today. I think you've done great on time, I have to say, because there is, of course, infinitely more to be said, if I may play this pun. Should have done. Now, we do want to take perhaps 5 minutes or so to look at some of the questions that we received from the live streams on YouTube and also on Bilibili. I will begin with one question, which may be a very difficult one, or perhaps not, I'm not sure, but it's up to you to decide, and I hope you will like it. The question is, how might one explain the problem of the infinite in a practical way. That is to say, is it perhaps the case that, and I suppose this is the idea that this might somehow not be possible, but is it perhaps the case that we could say that the problem is just logical? So I think the question makes a distinction between what's practical and what is perhaps just logical.
Good. Okay. Well, again, if I may say so, I think this points forward to later lectures. So in lecture 2 on Friday, I think we will see some examples of how these issues have practical repercussions. We'll be looking at some ways in which thought about the infinite has been applied in science and technology, and in particular thought about the infinitely small. We'll be looking at the calculus, and that's concerned with what's infinitely small, and that has been of huge practical significance, and we'll be seeing some examples of that. So these issues are not purely theoretical by any means. Now, in the third lecture next week, I'll be talking some more about the mathematics of the infinite, and the discussion will then turn to the infinitely big rather than the infinitely small. And quite often when there's discussion of the infinitely big, quite often this question arises, which is, does this have any practical significance, or is it just of purely theoretical interest? Now, the mathematics of the infinitely big has not so far been applied in the same way that the mathematics of the infinitely small has been. So whereas in Friday's lecture, we'll see lots of examples of practical applications, when it comes to the lecture next Wednesday, we won't see those practical applications. But there are two things I think to be emphasized. One is the mathematics does have applications elsewhere in mathematics. I mean, that's still very theoretical, but it has been of huge significance to other mathematicians. But also, as far as practical applications are concerned, we have to remember that this mathematics is still relatively recent, and very often in the history of mathematics and in the history of technology, the applications only appear quite a bit later. I mean, the mathematics appears first, and then it's subsequently that you find ways in which it can be applied. And I think it's still possible that we may find that there are practical applications. And then finally, if I can just say something about my fourth lecture, so this is looking ahead to next Friday. In my fourth lecture, I'll be talking about questions connected with our own finite nature, and some of the big questions that arise in connection with that, questions about death and immortality. Which, I mean, because we're finite, it means that it does have a kind of practical significance for us to think about the infinite and to think about ourselves in relation to the infinite. And those are very practical questions. I mean, they're some of the most fundamental questions of life. And of course, we've talked quite a lot about religion as well. I mean, I've mentioned religion a few times, and some of what Zhao Yu was talking about was concerned with religious thought as well. And religious thought is thought about how to live in a practical sense. So I think there are connections with what's practical. Yeah.
Yes, I think you've made that very clear. Thank you so much, Adrian. I do want to give you one final question. I think the answer to it could be super brief, or at least relatively brief, and I think you'll see why. Before I give it to you, I also want to just mention a few of the other questions that we had online, and perhaps generally the fact that many of them were indeed asking for elaboration and explanation of questions that have been discussed today. There's a question concerning the relationship between the infinite and the finite, how perhaps infinity may possibly only be defined or understood as the negation of finiteness. There's also a question concerning the nature of some of the theories and ideas that you have presented from the Western tradition. And then the question, in what aspect you may think that they are rooted in the West's own history and culture. So that is something which we have briefly touched upon today, if only to say that it is certainly something that would be very difficult to answer, of course. And now, there are various questions about Aristotle, of course. There are many questions about Aristotle. But what I want to perhaps make it our last question is this one. Could you please recommend some papers or books about infinity? And the super brief answer that you could give, as far as I know, is your own book. But perhaps I can put a spin on this question, which would be, are there any works other than your own which have influenced your own thinking? Is there anything that you believe has been of particular significance in your own thinking and understanding of the infinite?
Yes, I mean, there are a lot of really good introductions to the infinite. I mean, my own book is intended as an introduction to the infinite, and it covers all of these issues in a bit more detail. But there are a lot of books, and if anybody was able to get access to my book, they would see references to these other books in the bibliography, all the things that I refer to. But as regards what's influenced me in my own thinking about the infinite, all the philosophers and mathematicians that I discuss in my book, who have had important things to say about the infinite, have influenced me. So there are some philosophers who get entire chapters devoted to them. There are 3 philosophers who get entire chapters devoted to them. One of those is Aristotle, as you won't be surprised to hear. One of them is Kant, who is my own personal favorite philosopher, and I'm going to be talking some more about Kant tomorrow. Sorry, not tomorrow, on Friday. And the third one is Cantor, and he's the mathematician that I've already mentioned, who I'm going to be talking about in lecture 3. So those 3 thinkers have all been a big influence on me. The 4th person that I would mention doesn't have an entire chapter devoted to him in my book, but he does keep recurring throughout the book, and his ideas are very, very influential in terms of how I myself understand infinity. And this is the 20th century philosopher Wittgenstein. So I think those are the 4 thinkers who have had the biggest influence on me, and they've each got work on the infinite, which is mentioned in my own book. That's work that appears in the bibliography for my own book.
Thank you so much. That's super interesting and a beautiful combination of a super brief and a very brief answer to the question. So it's perhaps on me to say goodbye now, and I want to thank everyone first before we say goodbye. Thanks to the audience, thanks to our panelists Thank you all very much indeed. And thank you, of course, Adrian. Thank you so much, and see you, and hopefully all of you, on Friday. Okay.
Thank
Goodbye.
you. Thank you. Goodbye.